For question A, it says construct a 99% confidence interval for the proportion of vaccine-eligible people who had received the flu vaccine. Use your confidence interval to comment on the belief of the 45% of the vaccine-eligible people who had received the flu vaccine. Okay, so I basically got the information up top, and then I decided that this is a one proportional z interval. So, and that's the equation for that, because it's either a yes or a no. And the equation for that is p hat plus or minus z square rooted by p hat 1 minus p hat divided by n. And then I filled in all the information there. So for p hat, that would be the people that said yes, they did get vaccines divided by the total sample, plus or minus, this is the z-score, which is in between these two numbers, which you had to get, it's the 99% interval. So this would be the top 5%, and on the back is the other 5%. And then the exact number I got, I Googled it in between. I want to get the exact number, but it's in between 2.57 and 2.56. So, and then square rooted by 4.16, or 0.416, and that's basically this. And then parentheses minus 1 divided by p hat, which is 0.416, and then divided by n. Then I just keep doing the math, and you keep basically just plugging and multiplying out until you get to the end, which is this is the percent interval range, which is 0.38998 to 0.44236. Or in other terms, that's just 38% to 44%. So what does that mean? That's basically, if we did this test, if we kept doing this test, this is the percent range that the test would fall under. So most of the time, people would be vaccinated, or 99% of the time, people would be vaccinated either from the range of 38% to 44%. Okay, so what does that mean? It asks us to comment on the rule about that there's 45% of people get vaccinated. Well, to that I say that's most likely false from the data we've received, because in this, the 99% range doesn't go over 45%. So it's highly unlikely that 45% of the time people actually do get vaccinated, because again, the 99% range goes from 38 to 44%. So I'm going to say no, that's not plausible. So question B is asking us if we do another 99 interval confidence rating for a different survey, what is the number that we can have to guarantee the margin of error will be less or equal to 0.02? So I got the margin of error formula is and this is it. Margin of error equals z-score square rooted by p parentheses 1 minus p parentheses divided by 9. I filled that all in. So the margin of error they gave us is 0.02. So it'd be 0.02 equals 2.576, or that's equal to the z-score for a 99% interval, square rooted by 0.5, that's the p-value, parentheses 1 minus 0.5 divided by n. So the whole problem is basically dedicated around getting n by itself and then finding how much n is, because that's the survey size. So what did I do here? The square root, what is it? I squared the square root, giving us which affected everything, so giving us 0.02 squared equals 2.576 squared times 0.5 times 0.5 divided by n. And then I times n to get it on this side, and then divided 0.02 squared to get it below, which gives us that, and then I multiplied 0.5 times 0.5 to give us 0.25. And then these two things multiplied equals 1.658944 divided by 0.02 squared, and then if you do that all out, it'd equal 4,147.36. That's not the final answer though, because you have to get it's a survey, so these have to be whole people, and since it went over 4,147, I had to go up to equal 4,148. And so that is the smallest survey size that you can have to get a margin of error less than 0.02.